So let us discuss this example of open ball. Okay, we are already familiar with open ball definition and few examples also we have seen. I will write the definition of open ball first, okay, and then we will go for this example. See, open ball, okay, with center x and radius r is defined as it is a collection of all points of x. Okay, it is a collection of all points of x whose distance from x is less than r. So this is definition of open ball. So normally when we say the definition of open ball, what we do, we draw a diagram like this. Okay, so here we consider x, we take radius r, and we draw a ball. Okay, we draw a circle. Okay, we draw a circle and we say the points which lie inside a circle, those are elements of open ball, and the points lie on boundary and outside, those will not be elements of open ball. In a simple way we say the definition. But if you change the metric, okay, if we change the metric, the open ball need not to look like a circle. It can be square, it can be triangle, it can be anything. Okay, it can be half of plane, it can be anything. So see, with the help of these examples, we are going to see what will be the different types of open balls we'll get here. So let us start this example. See what we have. I will write, just a minute. I will remove this part. Okay, see. Okay, it is removed now. Okay, so what we have to find? We have to find, consider, I will write, consider, we have to find this open ball B 0, 0 and 1. Okay, so definition says what is our metric? That means what is our space? We have a R2 is a space. R2 is a metric space. So we have, it is, this open ball contains all elements of R2 whose distance, okay, so distance between xy and 0, 0 should be less than 1. R is 1 here. You can easily see. Getting? And D. So instead of D, we need to write D1 since the given metric is D1. Getting my point? Okay. So simply I use the definition and I wrote this one. So let us go further. So this is equal to xy belongs to R2 such that D1, they have clearly mentioned D1 is a metric induced by this norm 1. Getting? So the definition of D1 will be norm xy minus 0, 0 getting norm 1 less than 1, right? So this is equal to xy belongs to R2, correct? Xy belongs to R2 such that, see, do you know how to subtract? If we have two elements of R2, how to subtract? First component minus first component, second component minus second component. So therefore we will have x minus 0 x and y minus 0 y, norm 1 less than 1. So this is equal to xy belongs to R2, xy belongs to R2 such that norm 1, what is definition of norm 1? That is also given here. Definition of norm 1 is mod x1 plus mod x2. So here I can write mod x plus mod y less than 1. Okay, so that means it collects all points of R2 which will satisfy this condition, getting mod x plus mod y less than 1. So that means clearly I will mention, so therefore open ball B001 is a region bounded by mod x plus mod y is equal to 1. Getting? Bounded by mod x plus mod y. That means here we have considered equality. With the help of inequality, we cannot draw diagram. So what we do, instead of inequality, if we have less than, greater than, whatever we have, we first consider equality sign there. We draw the diagram and then we think about region. If it is less than, then we will consider a region inside, and if it is greater than, we will consider a region outside. So this is a simple technique we have. So make a screenshot of it, and after that we will go for the actual region, okay, actual open ball. Okay, so let us draw a diagram now. What we have? We have mod x plus mod y is equal to 1. So therefore See, you know that value of mod x can be plus 1 plus x minus x, or value of mod y can be plus y minus y. So if you consider all possibilities, we will have 4 equations. So that means if both of them are positive, we will have x plus y is equal to 1. If x is negative, y is positive. Second equation we get, if x is positive, y is negative, we will have the next equation. And if both of them are negative, we will have minus x minus y is equal to 1. So in this way, how many equations we have got? We have got 4 equations, right? So see, we will draw those curves, okay, and then we will get the region. See, x and y in all equations we have power of x is 1, power of y is also 1. So that means this is nothing but all equations represent straight lines, right? So this is a line. So a line passes through, okay, passes through actually which points in paper 1. In paper 1 we have, in our those videos we have seen how to find a line. What we do, first I am putting x is equal to 0. What I am doing, I am putting x is equal to 0. What will be the value of y if I put x is equal to 0? Y is equal to 1. So the first point 0 comma 1, and okay, and now I will put y is equal to 0. What I am doing, I am putting y is equal to 0. So what will be the value of x? X is 1. So the line passes through 0, 1 and 1, 0. Okay, I will draw the diagram simultaneously so you can easily understand. Just a minute, y-axis, this is our x-axis, okay, this is y-axis, this is x-axis. Rough sketch I will draw here, 1, 0 here, minus 1, 0, this one is 0, 1, this one is 0, minus 1, right? Okay, so this line passes through 0, 1, 0, 1 and 1, 0. Okay, I will draw dotted line. I will tell you why, dotted line. So this is the line we have got, which is x plus y is equal to 1. See, second is also a line which passes through, same logic I will apply, getting same logic I will use. I am putting x is equal to 0 first, so y is equal to 1, and if I put y is equal to 0, minus x is equal to 1, that means x is equal to minus 1. So second line passes through 0 comma 1 and minus 1 comma 0. So my second line will be like this, getting? This is my second line. Its equation is minus x plus y is equal to 1. Third line, okay, third line. So putting x is equal to 0, so y is equal to minus 1. And if you put y is equal to 0, x is equal to 1. So 0 comma minus 1, where is 0 comma minus 1 and 1 comma 0. Getting? So this is our next line, third line. What is its equation? I will write here, x minus y is equal to 1. Last one, see, last one, this is a line, see, minus x minus y. If I put x is equal to 0, y is equal to, sorry, x is equal to 0, y is equal to minus 1, and y is equal to 0, x is also equal to minus 1. So this line passes through 0 comma minus 1 and minus 1 comma 0. So this is a line which we have. Getting? So this is minus x minus y is equal to 1. That means x minus y is equal to minus 1. Okay. So see, therefore, the region bounded by these 4 lines, so that means this region we have, as well as, okay, we have considered equality, but what we had got strictly less than, so that's why it never contains its boundary. Getting? It never contains its boundary. That means we have to consider points which lie inside the region. We cannot consider point which will lie outside as well as on boundary. So therefore, this is a region which we have got. Getting? So region bounded by these 4 lines. This is a given open ball. Getting? Okay. So when we think about open ball, we always consider a circle, but actually it is not true. Okay. It depends on actually metric. Okay. So here for D1 we have got one square. Okay. So, this square we have got as an open ball here. Okay. So this problem is over. Make a screenshot of it, and after that we will stop. Thank you. Bye bye.